Objectives. At the end of this video, you will be able to: number 1. Start the compressor with a relay. Number 2. Start the compressor without a relay. Number 3. Installation of a new refrigerator. Number 4. Start the refrigerator unit. Number 5. Test the performance. Let us collect the tools and equipment required to do this practical. Cutting plier 200 mm, 1 number. Nose plier 150 mm, 1 number. Wire stripper 1 number. Screwdriver set 1 number. Line tester 500 volts 1 number. Clamp meter 0 to 500 volt AC 1 number. Multimeter 0 to 500 volt 1 number. Compressor hermetic FHP practical horsepower 1 number. Copper wire 1.5 mm square 4 meter. Thermometer stem or digital type 5 to 50 degrees Celsius 1 number. Spirit level 1 number. Domestic refrigerator 1 number. Voltage stabilizer 1 number. Insulation tape 1 number. Sandpaper as required. Thermal pin. Procedure. Task 1. Start the compressor with relay. Step 1. Take the 1/6 or 1/8 HP sealed compressor. Step 2. Fix the PTCR relay and OLP to the compressor terminals. Step 3. Provide power supply to the relay 230 volt AC. Step 4. Switch on the supply and start the compressor. Step 5. Check the current drawn by compressor. Step 6. Check the suction and discharge pressure by manual sensing. Step 7. Measure the current drawn by the compressor. Step 8. Switch off the power supply after testing over. Task 2. Start compressor without relay. Step 1. Check the 4 numbers of 1 meter length different color wire pieces. Step 2. Skin the wire at one ends. Fix the clip. Step 3. Connect the red wire into compressor R terminal series with the ammeter. Step 4. Connect the black wire into C terminals. Step 5. Connect blue wire to S terminal through push bottom switch. Step 6. Provide earthling for compressor with green wire. Step 7. Fix pin plug to red, black and green wire. Step 8. Press the push bottom switch. Step 9. Switch on the power supply. Step 10. Release the push bottom switch and see the running of compressor. Step 11. Check the compressor working suction and discharge. Step 12. Measure the current drawn by the compressor. Step 13. Switch off and remove wire after test is over. Connect the measure leads as follows. Connect the black lead negative to a known good earth reference such as a water pipe or earth rod. Connect the red lead positive to the conductor or component being tested for insulation resistance. Activate the measure to perform the insulation resistance test. A high resistance reading indicates good insulation, while a low resistance reading may indicate insulation deterioration or a potential fault. While checking the performance of the refrigerator, voltage, current, watts, temperature of the evaporator coil and vibration in the condenser are also to be checked. Recap. In this video, we have discussed how to start the compressor with a relay. Start the compressor without a relay. Hi everyone. In today's video, let us learn how to cleaning and flushing of evaporator and condenser with dry nitrogen. Objectives. At the end of this video, you will be able to number 1. Strip out the components from a conventional refrigerator. Number 2. Clean and flush the condenser coil with dry nitrogen. Number 3. Dry the condenser and evaporator coils with a hot air gun. Let us collect the tools and equipment required to do this practical. Flaring block and yoke 4.7 mm to 16 mm, one set. Swaging tool set or multiple tool in all sizes 1 by 4 inch to 5 by 8. Hammer ball pen 220 grams, one number. Measuring tape 2 meters, one number. Tube cutter 3 mm to 16 mm diameter, one number. Spanner double end 4.7 to 16 mm, one number. Cutting plier 200 mm. Nose plier 150 mm, one number. Screwdriver 10 mm tip 200 mm length, one number. Hot air gun, one number. Line tester 500 volts heavy duty, one number. Gas welding set, one number. Nitrogen regulator 2-stage with hand shut off valve, one number. Insulation tape, one number. Sandpaper, one number. Procedure. Task 1. Strip out evaporator coil and condenser coil from the refrigeration system for internal cleaning in conventional refrigerator. Step 1. Disconnect the electrical power supply to the refrigerator. Step 2. Remove the relay cover clip. Step 3. Gently pull the relay from the compressor terminal. Step 4. Keep away wire harness assembly from the torch flame reach. Step 5. Recover the refrigerant in service cylinder. Step 6. Allow 5 minutes to escape all the refrigerant gas from surrounding if any. Step 7. Flame the torch and adjust to neutral flame. Step 8. Debrace suction line capillary tube from the outlet dryer. Step 9. Unscrew the condenser coil mounting bracket. Step 10. Separate the condenser coil from the refrigerator. Step 11. Remove the door by unscrewing top hinge to enable to pull the evaporator coil from inside. Step 12. Check the evaporator coil mounting arrangement. Normally front portion mounted on 2 bolts, back portion lock arrangements. Step 13. Remove the mounting bolt, unlock the evaporator. Step 14. Remove the thermostat bolts from the evaporator. Step 15. Gently pull the evaporator from the refrigerator. Step 16. Debrace the suction line from the evaporator outlet and debrace capillary tube from the inlet of the evaporator coil. Step 17. Before debrace suction line and capillary tube from the evaporator, keep wet cloth on evaporator copper aluminium joints. Step 18. Now, the evaporator coil, condenser coil is ready for internal cleaning. Task 2. Clean and flush condenser and evaporator coil with nitrogen. Step 1. Clean the condenser external surface with wire brush. Step 2. Cut 150 mm length 6 mm tube for the coil. Step 3. Insert 6 mm flare nut at one end of the 150 mm copper tube and make 6 mm flare with the help of flaring block and yoke. Step 4. Swage other end to suit 6 mm Bundy tube with the help of flaring block and swage punch. Step 5. Insert swage tube to Bundy tube of condenser coil or evaporator coil. Step 6. Brace the joints, Bundy tube and copper tube with silver rod. Use suitable flux. Before bracing, it's crucial to ensure that the surfaces to be joined are clean and free of contaminants like oxidation, dirt or grease using emery sheets. Typical fluxes used for bracing different materials commonly found in refrigeration systems. They are copper to copper, copper to aluminium, copper to steel, aluminium to aluminium, and aluminium to steel. Step 7. Ensure the joint properly fitted with silver rod. Step 8. Check the small mirror opposite side are also covered properly. Step 9. Connect 6 mm straight union in the flare nut. Step 10. Check charging hose. Ensure rubber bushes are there in both ends. Step 11. Connect one end of charging line to dry nitrogen cylinder and hand shut off by tightening clockwise. Step 12. Connect the other end of charging hose to the straight union in the condenser coil or evaporator coil. Step 13. Unscrew the dry nitrogen cylinder regulator valve stem and keep the hand shut-off valve open. Step 14. Crack the nitrogen cylinder valve anti-clockwise, stem with the help of cylinder key. Step 15. Check the cylinder pressure in the nitrogen cylinder. Step 16. Slowly turn clockwise regulator spindle and maintain 7 kg per centimeter square outflow with the help of testing pressure gauge. Step 17. Hold your hand on condenser outlet. Step 18. Close the outlet mouth for few seconds with your finger, then leave your finger. Step 19. Repeat the above procedure till maximum 5 minutes. All the contamination come out. After flushing cap, the end of the condenser evaporator coil. Now the coil is ready for assembling. Flushing the condenser coil may involve handling cleaning solutions, chemicals, or debris that could irritate or harm the skin. Wearing gloves provides a physical barrier that protects your hands from contact with these substances, reducing the risk of skin irritation, cuts, or abrasions. Task 3. Dry the condenser and evaporator coil with hot air gun. Step 1. Connect the nitrogen cylinder as per the diagram. Step 2. Regulator 0.5 kg per centimeter square on the regulator to pass the nitrogen during drying operation to avoid air entry. Step 3. Switch on the hot air gun. Step 4. Hold the gun and warm the condenser coil right to left from top to bottom for 15 minutes. Check continuous rating of hot air gun. Step 5. Switch off hot air gun. Step 6. Remove the charging hose. Straight union plug the inlet outlet mouth with suitable cap. Step 7. Plug both ends with suitable caps. Step 8. Now the condenser coil ready for assembling. Recap. In this video, we have discussed how to Number 1. Strip out the components from a conventional refrigerator. Number 2. Clean and flush the condenser coil with dry nitrogen. Number 3. Dry the condenser and evaporator coils with a hot air gun. Hi everyone, in today's video let us learn how to identify and use of special tools, instruments and equipment used in refrigeration work. Objectives. At the end of this video, you can be able to Number 1. Identify the main parts of refrigeration tools and their functions of work in field. Number 2. Identify the measuring instruments used in refrigeration work. Number 3. Identify the equipments used in refrigeration work. Let us collect the tools required to do this practical. Flaring tool with yoke, 1 number. Tube cutter with reamer, 1 number. Pipe bender, lever and soaring type, 1 number. Swaging tool, 1 set. Pinching tool, 1 number. Pinching plier, 1 number. Ratchet wrench key, 2 numbers. Pressure gauge, 2 numbers. Compound gauge, 2 numbers. Thermometer, 1 number. Electronic detector, 2 numbers. Gauge manifold, 1 number. Tongue tester, 1 number. Anemometer, 1 number. Sling psychrometer, 1 number. Tachometer, 1 number. Single adapter hand shut of valve manifold gauge, 1 number. Vacuum pump, 1 number. Air compressor, 1 number. Procedure, Task 1. Identify the main parts of refrigeration tools with their function. Number 1. Identify the main parts of flaring tool. Number 1. Yoke assembly. Holds the tube or pipe securely in place during the flaring process. Number 2. Wink nut. Its primary purpose is to provide a quick and convenient way to tighten or loosen the tool's clamping mechanism. Number 3. Chamfer. The chamfer in a flaring tool serves a crucial purpose in preparing the end of a tube or pipe for the flaring process. Number 4. Flaring block or anvil. The flaring block provides support to the tube or pipe during the flaring process, helping to maintain its shape and alignment. Identify the main parts of tube cutter with reamer. Number 1. Grooved roller wheel. The grooves help to grip the tube securely, preventing slippage during the cutting process. Number 2. Cutting wheels. The cutting wheel in a tube cutter with a reamer is a critical component responsible for making clean and precise cuts in tubes. Number 3. Adjustable knob. This is responsible for holding the tube securely in place during the cutting and reaming operations. Number 4. Reamer. The reamer blade is a component designed for removing burrs, rough edges and other imperfections from the inside of a tube after it has been cut. Number 3. Identify the main parts of pipe bender. Number 1. Degrees of bend. The degree of bend refers to the angle through which the pipe is bent from its original straight position up to 180 degrees. Number 2. Operating lever. The lever is connected to the bending die or shoe which holds the pipe in place. By applying force to the lever, the user can gradually bend the pipe to the desired angle. Number 3. Tube. The bender must be appropriate for the size and thickness of the tube to ensure proper bending without causing damage or deformation. Number 4. Bending tool. It is used to shape a piece that supports the pipe during bending and imparts the desired curvature to the pipe. Number 5. Gain scale. Proper adjustment of the gain ensures that the bending force is appropriate for the material and diameter of the pipe being bent. Number 6. Clamp. The clamp prevents the pipe from slipping, rotating or moving out of position, ensuring that the bending operation is accurate and controlled. Number 7. Spring-type tube bender. External coil spring bending tools where the external spring is designed to be used near the ends of tubes. Task 2. Identify the instruments used in refrigeration work. Number 1. Identify the main parts of pressure gauge and compound gauge. Number 1. Rubber seal. A rubber seal plug can act as a protective barrier, preventing moisture or corrosive agents from reaching the gauge's connection points. Number 2. Needle. The position of the needle directly indicates the pressure in the unit of a measurement displayed on the gauge. Number 3. Socket. The socket often includes a sealing mechanism such as threads or O-rings to create a tight seal between the pressure gauge and the system. Number 4. Vacuum scale. The vacuum scale provides a direct indication of the vacuum level within a system. Number 2. Identify the main part of thermometer. Number 1. Boiling temperature of water. The boiling point of water is 100 degrees Celsius and 212 degrees Fahrenheit. Number 2. Standard temperature of water. The standard temperature of water is 20 degrees Celsius and 68 degrees Fahrenheit. Number 3. Freezing temperature of water. The freezing point of water is 0 degrees Celsius and 32 degrees Fahrenheit. Number 4. Glass stem. The stem is the elongated tubular part of the thermometer that typically contains the temperature scale and the temperature sensing element such as mercury or alcohol. Number 5. Bulb. The bulb is a sealed chamber at the bottom of the thermometer that contains a thermometric fluid such as mercury or alcohol. Number 3. Identify the main parts of halide torch leak detector. Number 1. Burner. The burner in a halide torch leak detector produces a flame, typically a hydrogen flame. This flame serves as the source of the heat for the detection process. Number 2. Control knob. The control knob may allow users to adjust the intensity of the flame produced by the torch. Number 3. Hose. The hose allows for directional detection by providing a means to draw in air from specific directions or areas. Number 4. Identify the main parts of electronic leak detector. Number 1. Power on or off button. It is used to switch on and off the device. Number 2. Sensor. Sensors in leak detectors are designed to detect the presence of specific gases or fluids. Number 5. Identify the main parts of sling psychrometer. Number 1. Handle. The handle allows the user to rotate the entire psychrometer assembly. Number 2. Wet bulb thermometer. The wet bulb thermometer relies on the cooling effect of evaporation to measure the wet bulb temperature accurately. Number 3. Dry bulb thermometer. The primary purpose of the dry bulb thermometer is to measure the dry bulb temperature, which represents the actual air temperature in the surrounding environment. Number 4. Water-soaked wick. The water-soaked wick is designed to enhance the cooling effect due to evaporation. Task 3. Identify the equipments in refrigeration work. Number 1. Identify the main parts of vacuum pump. Number 1. Vacuum gauge. The primary purpose of a vacuum gauge in a high vacuum pump is to measure and display the vacuum level within the system. Number 2. Vacuum hose. The vacuum hose serves as the conduit for the transfer of vacuum between the high vacuum pump and the system being evacuated. Number 3. Metal stand. To hold and carry the entire system. Number 2. Identify the main parts of air compressor. Number 1. Air compressor. The compressor circulates the refrigerant throughout the refrigeration system in a continuous cycle. Number 2. Pulley. The primary purpose of the pulley is to transmit power from the electric motor to the compressor pump. Number 3. Belt. The purpose of the belt in an air compressor is to transmit power from the motor prime mover to the compressor pump. Number 4. Motor. The motor provides the rotational force required to operate the compressor pump. Number 5. Air tank. The primary purpose of the air tank is to store compressed air generated by the compressor. Recap. In this video, so far we have discussed how to: Number 1. Identify the main parts of refrigeration tools and their functions. Number 2. Identify the measuring instruments used in refrigeration work. Number 3. Identify the equipments used in refrigeration work. Hi everyone. In today's video, let us learn how to identify the various refrigeration equipment's compression of vapor compression system and vapor absorption system. Objectives. At the end of this video, you can be able to: Number 1. Identify various refrigeration equipment. Number 2. Identify the system and trace out the cycle. Number 3. Identify the components of the vapor compression system. Number 4. Identify the vapor absorption refrigeration cycle. Let us collect the equipment required for this practical. Vapor compression system 1 number. Vapor absorption system 1 number. Procedure. Task 1. Identify various refrigeration equipments. Number 1. Let us look into the parts of refrigerator. Serial number 2. Let us look into the parts of visible cooler. Serial number 3. Let us look into the parts of the water cooler. Serial number 4. Deep freezer. Ice candy plant. Soft machine. Task 2. Identify the vapor compressor system and trace out the cycle paths. Serial number 1. Identify the components in the system. Compressor motor. Number 2. Discharge line. Number 3. Condenser. Number 4. Liquid line. Number 5. Receiver. Number 6. Filter or driver. Task 3. Identify the components of vapor compression system. Number 1. Compressor. The function of the compressor is to provide the necessary pumping action to the refrigerant. It draws cool refrigerant in through the suction line from the evaporator. It compresses it and discharges it into the condenser where it is liquefied. The compressed gas has rise in temperature and pressure at the time of entering condenser. Number 2. Condenser. The main purpose of the condenser is to release heat from the refrigerant, which has absorbed heat from the interior of the refrigerator. As the high pressure, high temperature refrigerant gas enters the condenser, it undergoes a phase change from a gas to a liquid while releasing heat to the surrounding environment. Number 3. Discharge line. After the refrigerant is compressed by the compressor, it becomes hot and pressurized. The discharge line carries this hot refrigerant vapor away from the compressor to begin the process of cooling down. Number 4. Liquid line. After the refrigerant has been condensed in the condenser coils, it becomes a high-pressure liquid. The liquid line is responsible for conveying this high-pressure liquid refrigerant to the expansion device, which regulates its flow into the evaporator coils. Number 5. Receiver. The receiver helps to regulate the flow of refrigerant within the system. It ensures a steady supply of liquid refrigerant to the expansion device, which controls the rate at which refrigerant enters the evaporator coils for cooling. Number 6. Filter or driver. The filter dryer serves two main purposes: filtering out contaminants and moisture from the refrigerant and acting as a reservoir for excess refrigerant oil. Number 7. Thermostat bulb. The thermostat bulb contains a temperature-sensitive substance, often a gas or a liquid, that expands or contracts based on the temperature surrounding it. The bulb is typically located in the fresh food compartment or freezer section of the refrigerator. Number 8. Relay. The relay acts as an electrical switch that opens or closes the circuit to the compressor motor when the thermostat signals that the temperature inside the refrigerator is too high. The relay closes the circuit, allowing electrical power to flow to the compressor. Number 9. Cooling coil. The primary function of the evaporator coil is to absorb heat from the substance or space being cooled. As the refrigerant flows through the coil, it undergoes a phase change from a liquid to a gas, absorbing heat from the surroundings in the process. Task 4. Identify the vapor absorption system and the cycle. Condenser. The condenser typically consists of coils or tubes that are cooled by either air or water. As the hot refrigerant gas flows through these coils, it releases heat to the surrounding environment, either air or water. This causes the refrigerant to lose energy and transition into a liquid state. Separator. The separator helps to separate these two components, ensuring that the oil returns to the compressor while the refrigerant continues its cycle through the system. Absorber. The primary purpose of the absorber is to absorb the refrigerant vapor that has been released from the evaporator. Generator. The primary purpose of the generator is to release the refrigerant from the concentrated solution that has been previously absorbed in the absorber.
Recap. In this video session, we have discussed how to Number 1. Identify various refrigeration equipment. Number 2. Identify the system and trace out the cycle. Number 3. Identify the components of the vapor compression system. Number 4. Identify the vapor absorption refrigeration cycle. Hi everyone. In today's video, let us know how to swage and make a braced joint on copper tubing. Objectives. At the end of this video, you can be able to Number 1. Swage a copper tube 6 mm. Number 2. Make a braced joint.
Let us collect the tools and consumable items required for this practical. Steel rule 1 number. Triangular file 150 mm 1 number. Clearing block 1 number. Swaging tool set 1 number. Ball peen hammer 225 grams 1 number. Handy braking torch 1 number. Brazing rod as required. Brazing flux as required. Butane 1 number. Oil as required. Cotton waste as required. Soft emery sheet as required. Copper tubes as required. Procedure. Task 1. Swage the end of the tube. Step 1. To join two pieces of tube of the same size together, one must be made larger so that the other fits inside. Step 2. Making the end of a tube larger is called swaging. Step 3. Examine the pipe swaging tool and compare it with the drawings. Make sure that you understand how it works before starting to swage the end of a pipe. Step 4. Place the tube in the tool. Make sure that you have chosen the correct size hole to fit the tube. Step 5. Position the tube so that the end is the outside diameter of the tube plus 1/8 inch. 3 mm above the top of the swaging block. For 1/4 inch 6 mm pipe, this will be 1/4 inch 6 mm plus 1/8 inch 3 mm is equal to 3/8 inch 9 mm. Step 6. Tighten the nuts at each end of the swaging block. Step 7. Choose a punch of the right size to swage out the end of the tube so that another piece fits inside. Oil the punch. Fit the clamp and punch onto the swaging block. Twist the handle and force the punch into the tube. Step 8. The punch will open out the end of the tube. Task 2. Brace a swaged joint. Step 1. Make sure that the tube enters the swage properly. It must be an easy fit. If it is a tight fit, there will be not sufficient space of the bracing material. If it is a loose fit, the joint will be weak. Step 2. Mix a little flux powder with spirit or water to make a stiff paste. Step 3. Apply a small amount of flux to the surfaces to be joined. Only a small quantity is necessary. Too much will contaminate the system. Note: if self-fluxing brazing rods are being used, this stage of the work is not necessary. Step 4. Push the end of one pipe into the swage of the other as far as possible. Turn the pipes to spread the flux. Step 5. Heat the joint with the blowtorch. Use a flame of the right size. Step 6. Wait until the joint is dull red. When the brazing rod starts to melt, the joint is at the right temperature. This temperature is found by torching the brazing rod onto the joint from time to time while heating. Do not overheat the joint. Do not leave the brazing rod in the flame. The brazing rod must be melted by heat of the joint and not by the flame. Step 7. When the right temperature has been reached, touch the joint with the brazing rod at several points. Step 8. Molten brazing rod will be drawn into the joint and fill the space between the outside of one pipe and the swaged end of the other. When a complete ring of brazing material can be seen at the end of the swage, remove the blowtorch. Step 9. Allow the joint to cool. Do not move either pipe until the brazing material has hardened. Observation table. Serial number 1. Parameter. Testing the swaging. Remarks. Excellent, good or average. Number 2. Testing the brazed joint. Firm or blowholes. Number 3. Time taken. Slow, medium or fast. Number 4. Materials waste. Less, very less or no waste. Note: repeat the same exercise for various sizes of tube and test the improvement.
Recap. In this video, we have discussed how to Number 1. Swage a copper tube 6 mm. Number 2. Make a brazed joint. Hi everyone. In today's video, let us learn how to make flare joints and test them with flare fittings. Objectives. At the end of this video, you can be able to Number 1. Make flares on copper tubes. Number 2. Join with flare fittings. Number 3. Test the leak in the fittings.
Let us collect the tools and materials required to do this practical. Flaring block with yoke 1 set. Adjustable wrench 200 mm 1 number. Valve key 6 mm. Cylinder valve opener 1 number. Pressure gauge with adapter 1 number. Flat file smooth 200 mm 1 number. Nitrogen cylinder with gas 1 number. Copper tubes 6 mm as required. Flare nut 6 mm size as required. Union 6 mm as required. Soap solution with stirrer as required. A small quantity of oil as required. Procedure. Task 1. Make flare on copper tubes. Step 1. Refrigerator pipes are sometimes joined to fittings by making a flared connection. Step 2. The end of the pipe is opened out to form a cone. Step 3. Always place the special flare nut on the pipe first before flaring. Step 4. Examine the tube flaring tool. Make sure that you understand how it works before starting to flare the end of a pipe. Step 5. Make sure that the end of the tube is free of rough edges before flaring. Step 6. Place the tube in the tool. Make sure that you have A. Place the flare nut into the tube. B. Choose the correct size hole in the flaring tool to fit the pipe. There are 5 holes to fit different sizes of pipe. Step 7. If the pipe is 1/4 inch 6 mm in diameter, position the tube so that the end is at least 2 mm above the top of the flaring block. This distance is calculated as pipe diameter divided by 3. In this case, 6 mm divided by 3 is equal to 2 mm. Step 8. Tighten the nuts at each end of the flaring block. See drawing. Step 9. Fit the yoke to the flaring block. Step 10. Oil the cone and slowly screw it into the end of the pipe. Step 11. The end of the tube will be formed into a flare. Step 12. Remove the flared tube from the block. Step 13. Examine the flare. If it has cracked, the cone was screwed down too quickly. Step 14. Make sure that the flare is the correct size. It should just fit inside the flare nut. If it is too loose, cut off the flare. Step 15. Position the tube so that the end is at least 3 mm above the top of the flaring block. Repeat until the flare is the correct size for the flare nut. not too loose and not too tight. Observation Table 1, Serial Number 1, Skills, Checking flare, Remarks, Cracked, Uneven, Too small, Too long or correct. Number 2, Number of attempts, 1, 2 or 3. Note, repeat the steps to the various sizes of copper tube. Task 2, Join with flare fittings. Step 1, push back the flare nut and place the flare tube on the fitting. Then tighten the nut using adjustable wrench or suitable double-end spanner. Step 2, tighten the one end of the tube to the dry nitrogen cylinder with the flare nut. Always use safety valve with double stage pressure regulator while ring dry nitrogen. Step 3, connect a pressure gauge at the other end of the tube with flare nut. Note, do not give more pressure while tightening since this will spoil flare. Make sure that they should not be loose in the tube. Observation Table, Serial Number 1, Skills, Selection of correct fittings. Remarks, correct or not correct. Number 2, Joining method, excellent, good or fair. Number 3, time taken, less, very less or more. Task 3, test the leak in fittings. Step 1, after joining the tube firmly, open the cylinder valve with the help of valve key or ratchet. Step 2, the pressure will be shown in the pressure gauge. Step 3, then close the cylinder valve. Major leaks will make noise and that needs the nut to be tightened. Step 4, if there is no leak, the pressure in the pressure gauge will remain constant. Step 5, if it decreases, check the joints with soap solution foam, leak with bubble, then tighten the joints. If it stands still, then there is no leak. Observation Table 3, Serial Number 1, Skills, Selection of tools, Remarks, excellent, good or average. Number 2, detecting leak and arresting, excellent, good or average.
Recap. In this video, we have discussed how to Number 1, make flares on copper tubes. Number 2, join with flare fittings. Number 3, test the leak in the fittings. Hi everyone, in today's video, let us learn how to pinch off copper tubing knob. Objectives. At the end of this video, you can be able to Number 1, pinch off the copper tube using a pinching tool and check for leakage in the tube.
Let us collect the tools and materials required to do this practical. Tube cutter with reamer, 1 number. Small triangular file, 1 number. Pinch off tool, 1 number. Steel rule, 1 number. Soft tubing, 1 by 4 inch, 3 by 8 inch, 1 by 2 inch, 1 roll each. Clean cloth as required. Pinching tools. It is used for sealing or closing the diameter of copper tubes. It consists of 2 bars forming jaws and holes of various sizes and are clamped together using nuts and bolts. Pinching of copper tubing using a pinching tool can be a method of temporarily stopping the flow of a fluid, liquid or gas through the tubing. This can be useful in various situations such as during maintenance or repairs. Procedure. Task 1. Pinch off the copper tube using pinching tool. Step 1. Unroll 1 by 4 inch soft copper tubing so that a 3 inch piece may be cut. Step 2. Measure 3 inch piece long tube using the steel ruler and mark it by nicking the face with a triangular face. Step 3. Cut the copper tube by placing the tubing in V-guide of the cutter. Cutting copper tubing using a tubing cutter is a common and effective method. The V-guide or groove on the cutter provides stability and helps guide the cutting wheel along a straight path. Step 4. Tighten the thumb screw until considerable pressure is applied. Step 5. Resolve cutter slowly around the tubing. Step 6. Seal the end of the tubing coil after cutting off the required piece. Step 7. Ream and file the edges of the tubing. Reaming and filing the edges of copper tubing is an essential step when working with copper pipes to ensure a smooth and clean surface. This helps prevent leaks, facilitates the proper insertion of fittings, and enhances the overall integrity of the plumbing system. Step 8. Repeat the same steps with other sizes using 3 by 8 inches and 1 by 2 inches tube. Step 9. Place copper tube in the pinch-off section of the tool. Apply even pressure by turning screws equally by hand. Step 10. Take a part turn on one screw and then an equal amount on the other. Step 11. The tightening process must carry on until the two blocks are evenly seated. Step 12. The tube is then pinched shut. Step 13. Apply a water and soap solution to the pinched area and any other potential leak points. Look for bubbles, which indicate escaping air and thus a leak.
Recap. In this video, we have discussed how to pinch off the copper tube using a pinching tool. Hi everyone, in today's video, let us learn how to use lock ring tools, various fittings of lock ring for servicing of appliances. Objectives. At the end of this video, you can be able to: Number 1. Connect two copper tubes with lock ring. Number 2. Connect capillary tube by lock ring fitting.
Let us collect the tools and materials required to do this practical. Tube cutter, 1 number. Tube caliper, 1 number. Digital micrometer caliper, 1 number. Lock ring tool kit, 1 number. Sandpaper as required. Lock prep adhesive, 1 number. Lock ring various sizes, 1 set. Copper tubes as required. Let us discuss the purpose of lock ring in the copper tubes. Lock ring is a brand that produces mechanical pipe connectors for various applications, including joining copper tubes. Lock ring connectors are known for their innovative design, which eliminates the need for traditional welding or brazing methods. Instead, lock ring connectors use a cold mechanical forming process to create a reliable and leak-free joint. The primary purpose of lock ring connectors in copper tubes is to provide a reliable, leak-free and efficient connection without the need for welding, brazing or other heat-based methods. Procedure. Task 1. Connect two copper tubes with lock ring. Step 1. Cut the copper tubing to the desired length using a tubing cutter. Step 2. Use a deburring tool to remove any burrs or rough edges from the cut ends of the copper tubing. This helps ensure a smooth and even surface for the lock ring connector. Step 3. Select the correct lock ring size and materials. Sizes are available range from 1.6 mm to 35 mm. Step 4. Check the size of the tubing with tube calipers. For accurate measuring, use digital micrometer caliper if available. Step 5. Set the tube and lock ring fitting in horizontal line. Step 6. Use the lock ring hand tool. Compress the fitting over the joint. Step 7. Apply the sealant lock prep adhesive on the tube outer space and rotate the tubes. Step 8. Now compress fully till the locking have tight close. Step 9. After completing lock ring fitting, clean the lock ring and joints with a dry cloth. If connecting two tubes, repeat the process for the other end of the copper tubing using another lock ring connector. Step 10. Inspect the lock ring connections to ensure that they are properly seated and the tubing is securely connected. Lock ring connectors are designed to provide a reliable and leak-free joint. Task 2. Connect capillary tube by lock ring fitting. Step 1. Use the tube cutter to separate the tubing if necessary. Step 2. Clean the capillary tube end with sandpaper. The goal is to remove any surface contaminants without causing damage to the capillary tube. A grit of around 400 or higher is suitable. Step 3. Pass the capillary tube all the way in until it reaches the other end of the looping connector. Like slide the lock ring connector onto one of the cut ends of the copper tube. Ensure that the lock ring connector is fully seated and covers the entire circumference of the tube. Step 4. Apply a single drop of lock prep while partly inserted in the lock ring. Lock prep may provide some level of corrosion protection for the joint. The adhesive can create a barrier that helps prevent the development of corrosion between the tube and lock ring fitting. Step 5. Rotate the fitting 360 degrees to spread the sealant evenly around the tubing. Step 6. Place a slight bend into the capillary tube. Step 7. Insert other end with copper tube and refer steps in connect two copper tubes with lock ring to complete the lock ring connection. Step 8. After completion of joint, wipe the joints with tri-cloth.
Recap. In this video, we have discussed how to Number 1. Connect two copper tubes with a lock ring. Number 2. Connect the capillary tube by a lock ring fitting. Hi everyone, in today's video, let us know how to identify the electrical and mechanical components of refrigerator direct cool and frost free. Objectives. At the end of this video, you can be able to Number 1. Identify the electrical parts and components of the refrigerator. Number 2. Identify the mechanical components of the refrigerator.
Let us collect the tools and materials required to do this practical. Screwdriver, 1 number. Line tester, 1 number. Combination insulated hand plier, 1 number. Series test lamp, 1 number. Multimeter, 1 number. Cotton waste or cloth, 1 number. Loose wire, as required. Refrigerator direct cool and frost free fill accessories, 1 number. Terminal pin, 1 number. Procedure. Task 1. Identify the electrical parts. Step 1. Disconnect the connection and identify the electrical components. Step 2. Keep it on workbench. Step 3. Clean all the spare parts. Step 4. Record the name of electrical parts of the given tabulation. Number 1. Capacitors. Capacitors in refrigerator systems are often associated with single-phase induction motors, such as those used in compressors. Capacitors create a phase shift in the motor windings, which generates a rotating magnetic field. This rotating field produces torque, helping the motor overcome resistance and initiate rotation. Number 2. Thermostat. The primary purpose of the thermostat is to control and maintain the desired temperature within the refrigerator or freezer. It monitors the temperature inside the compartments and activates or deactivates the cooling system accordingly. Number 3. Automatic defrost timer. The evaporator coils in a refrigerator are responsible for removing heat from the air inside the freezer or refrigerator compartment. During normal operation, moisture in the air can condense on these coils, forming frost and ice. Over time, This frost accumulation can reduce the efficiency of the refrigeration system by preventing excessive frost buildup on the evaporator coils. The automatic defrost timer helps maintain the efficiency of the cooling process. Number 4. PTC relay, positive temperature coefficient relay. A positive temperature coefficient (PTC) relay is a crucial component in a refrigerator system. Its primary purpose is to control the starting and stopping of the compressor, which is responsible for circulating refrigerant and maintaining the desired temperature inside the refrigerator or freezer compartments. The PTC relay is responsible for initiating the starting sequence of the compressor. Number 5. Evaporator fan motor. The evaporator fan motor in a refrigerator plays a crucial role in maintaining proper temperature distribution and ensuring efficient operation. The primary function of the evaporator fan motor is to circulate air inside the refrigerator. It draws air across the evaporator coils, where heat is absorbed from the interior, and then distributes the cooled air throughout the refrigerator and freezer compartments. Overload protector (OLP). The overload protector is a safety device designed to protect the compressor from electrical overload. Defrost heater. This heater is located either behind or underneath the evaporator coils in the freezer compartment. Its primary function is to melt frost and ice that accumulates on the evaporator coils during the cooling process. Thermal device. Thermal devices such as thermal switches or thermal protectors are used to monitor the temperature of certain components in the refrigeration system. Bulb with switch. In some refrigeration systems, a bulb with a switch is used as a part of a temperature control mechanism. The bulb contains a temperature-sensitive fluid that expands or contracts based on changes in temperature. Task 2. Identify the mechanical parts. Step 1. Disconnect the electrical connection and identify these mechanical components. Step 2. Clean all these parts. Step 3. Record the name of mechanical parts given in the tabulation. Number 1. Compressor. The function of the compressor is to provide the necessary pumping action to the refrigerant. It draws cool refrigerant in through the suction line from the evaporator. It compresses it and discharges it into the condenser where it is liquefied. The compressed gas has rise in temperature and pressure at the time of entering condenser. Number 2. Condenser. The function of the condenser is to remove the heat carried by the refrigerant and return the refrigerant to the control, enabling the system to repeat the cycle. Number 3. Strainer. The strainer is designed to trap and remove debris, particles, or contaminants present in the refrigerant circuit. The primary function of the strainer is to protect critical components of the refrigeration system, particularly the expansion valve and other precision components. Number 4. Capillary tube. The capillary tube in a refrigerator is a narrow, long tube that serves as a metering device in the refrigeration system. Its primary purpose is to control the flow of high pressure, high temperature liquid refrigerant from the condenser to the evaporator. The capillary tube reduces the pressure of the refrigerant, transitioning it from the high pressure liquid state, leaving the condenser to a low pressure liquid state before entering the evaporator. Number 5. Cooling coil. The primary purpose of the cooling coil is to absorb heat from the air inside the refrigerator or freezer compartments. This heat absorption is facilitated by the refrigerant circulating through the coils in a low pressure, low temperature state. Gas changes liquid to vapor position and produce cooling in freezer coil.
Recap. In this video session, we have discussed how to number 1. Identify the electrical parts and components of the refrigerator. Number 2. Identify the mechanical components of the refrigerator.
So in this presentation, I will be discussing on the topic of provision of construction joint in RC frame structure. Now we will see the construction joint at the column beam junction of the frame structure. As we know that the beam column junction is the crucial zone in